All right, for this milestone presentation, I'm just going to have go ahead and quickly cover the fact that I've been coordinating with the other programmers and the other leads, and the fact that I've been taking charge and built the AI. So after testing 6 different implementation methods on how to deal with the AI in Traffic Cop, I eventually ended up settling on. I eventually ended up settling on one that was primarily the most effective exercise of resources for the game, namely because we're aiming for the 8 GB platform of the Oculus Quest 2. So I had to make sure that the information management, the data management wouldn't exceed the limits set by the platform, our target platform. Um, some of the other considerations were making sure that it maintained an accurate level of realism for the vehicle movement, and to that ends, I couldn't just use a straight up rendition of the nav mesh system combined with the waypoint system that I was using, because that would produce mechanics or effects that would not be completely accurate to the mechanics of the video game itself and the motion that the cars make as they're moving throughout the video game environment. So one of the main things that ended up resulting from these limitations was the use of the nav mesh still, because it's better than just having them float from point A to point B with no real sense of placement or anything else, and the use of trigger boxes, which will change the movement allowance state for the game objects whenever they run into it. So what we have going between point A and point B is we have the spawn boxes here, which are responsible for spawning the assets. These were already present in the last build. And then we have these new trigger boxes, like right here, which are responsible for letting a car know if it can or can't go. Now, one of the most unique things for that is actually been done here in the central AI controller, and I'll pop that open to give a showing of the blueprint and how it's evolved. So initially with the event ticks, the event tick just originally went into the pathfinding here to tell it to go to the various waypoints. But now, as we can see here, it actually comes second in the sequence, and this is the whisker. Uh, it's it uses a raycast to determine what's in front of it and if it can go or can't go. I call it the whisker because I'm using the whisker and cat box. So this is the box, and this is the whisker. And the whisker, as you can see here, using the multi-line trace for objects. The multi-line trace for objects is actually a raycast that goes out in front of the vehicle. And as you can also see here, the instigator, which is the car that the AI eventually ends up getting assigned to, is one of the things that it ends up ignoring. That's kind of important because otherwise it does circular referencing, and that is bad. Take my word for that. But what it does is it basically just checks to see what it's running into. And since we only have really 2 types of pawn object that it can run into, it will just attempt to do casts to those pawn objects. And depending on the way that it interacts, it always pulls the derivative class, the AI possessor, if the AI possessor is actually an AI controller car. And when it's successful in doing that, it will update this vehicle's current can move with the one that the raycast runs into. So, in very simple terms, the car stops when the car in front of it is stopped. But the way that it manages to do that is it references the can move of the car in front of it, and it has to do that by pulling the cast to AI controller car, which is interesting. There's a lot of interchangeability, and but this is the way it works in blueprints. And this is just the debug for it. And then down here, as we can see, In spite of the way it was previously, I had to include an additional branch for the can move. And we could see that when the can move is false, it immediately stops the AI. Before I had implemented that particular method, it would continue on to the next waypoint and then stop at that once it had managed to reach that desired point. But that is literally the only addition that I made to the actual movement method was this branch condition, adding in the can move, and telling it to stop where it's currently located. And we can see that it just gets that from taking the actor location, which is get controlled pawn, and it uses the return value from get controlled pawn to go ahead and set the destination to where it's currently at, which is extremely helpful. Um, Instigator works better for this because Instigator actually will maintain the line trace as anchored on not the original location of the pawn, but the actual instigator in and of itself. So it instigates it from the possession of the pawn, and since the possession is always connected or contained within the pawn itself, it makes sure that every time that it's calling the ray trace, that it's actually instigating from where the pawn is currently at instead of where the pawn used to be, which is why get controlled pawn doesn't work up here, but instigator does. It was kind of a strange occurrence. I'm skipping over a lot of stuff that I had to work through. I eventually ended up deciding on this method of AI because it met the most criteria the best. It wasn't the simplest to calculate. It wasn't the most accurate to run, and it wasn't the least involved. The least involved was just directly using NavMesh and declaring the vehicles to be world dynamics, and then having world dynamics as something to be avoided. In that instance, although it was very effective, the vehicles didn't move in an intelligent sense or in a normal vehicular sense, and it was too smart. The vehicles would not run into each other during such a setup, and that is directly contradictory to the gameplay that we were after. So just using the nav mesh was ruled out. So we eventually got to the point where I used the existing waypoint system that I already have, and I combined that with the whisker system that I have up here, which is it uses the box. So it's the cat in the box system, because it uses the whiskers to determine what the vehicles in front of it are doing, just like if somebody was driving a regular car. And we'll see shortly here exactly what that looks like when it's in action. And the box, which is the trigger box, so when the vehicles enter it, it can change the vehicle that enters it, the movement state, which is nice. And then the vehicles behind it, because of the whisker system, when they touch the vehicle in front of it, they're able to read the state that vehicle has and therefore stop. So, and as we'll see when we run it here, the vehicles end up behaving in a very realistic fashion. Let me go ahead and zoom out so you can see. Here that when the whisker touches the vehicle in front of it, and the vehicle is set to the can move for that is set to false, and the can move for that is set to false, you can see that it actually stops the vehicle itself. So if we go ahead and set that to true, you can see the vehicles will immediately move back into motion because the vehicle in front of them is now capable of moving. And you'll be able to see that once again when we click the can't move again, the instant it overlaps it, it sets the movement ability to can't. And as you can see here, it will automatically propagate that to any other vehicle that manages to touch the vehicle in front of it with a ray trace. And it will pass along the properties that it's wanting to choose, which in this state is the can move, and then forcibly updating that to the vehicle's to itself. And then the ray trace picks that up from everything else. So the vehicle in front here, as soon as it's entering this trigger box, it's changing its movement ability from can move to can't move. And then the vehicles behind it, like this one, oh, I clicked. Like this one here, As soon as the ray trace touches the vehicle in front of it, it picks up the can move variable from that vehicle and alters its own state as well. So as you can see here, the cars will actually space depending on what the raycast distance for the ray trace is. And this is really helpful because it gets the very realistic vehicle spacing, and we can actually alter the amount of space that it gets by the stuff in front of it. And the other way that this could have been done was with like a flocking or a grouping behavior using the AI. But using this method, you can actually see that the vehicles behave in a realistic fashion without having to be kept and sorted and ordered through an array, which was a very, very key consideration for dealing with the array, dealing with the amount of space and volume memory-wise that we would have for the Quest 2, because this means that I don't have to deal with array sorting or array manipulation directly to access or alter the needs of the vehicles here. And doing that means that, as you can see here, I'm having very little problem, even though I have an absolute ton of vehicles spawned on the map. I don't have to worry about scaling up an array to do it because it's doing function return procedures instead of doing array management and multi-object manipulation through a top-down array. I'm able to just have the vehicles stack up and stop automatically based on real-world stimuli, or based on the game environment stimuli, which means they behave in a visually much more logical fashion than if they were to just go off of the basis of the can move and can't move. As we can see here, just because these aren't set up on a path, they don't necessarily, the vans aren't activating when a can move is in front of it, but the main reason they were just set up like that was so that they would deliberately crash, so that's not much of an issue right now. But as you can see here, when the vans run into a situation where the vans in front of them aren't moving, then they go ahead and skip the crash phases. Or when they get stacked up like that, they'll go ahead and self-destruct. But with the way that I'm very happy with the way that the AI is now working. The only issue that I've run into is that since the trigger box is not a player character and does not inherit from the player character classes, that when I attempted to put keystrokes into it in order to get it to be set up for a tech demo where people could just press a key and get it moving in the method that they wanted, that since it's not a player character, it doesn't actually listen for key press inputs. This won't be a problem for the VR build because I can use the same kind of method that I'm using for the cars to drag in the query after I can just use the straight up trigger box and I can just tell it to look for the channel of the trigger box. And I'd be able to switch it using that method through the VR player control. But as it is right now, I can't just use a key push inside of the trigger box in order to get it to change its state because it's not listening for the inputs. So it won't be much of an obstacle for when we actually do the VR, because doing a raycast from the hand in VR is simplicity itself. But getting the trigger box itself can't directly recognize inputs, and I probably should have tested out how to change the variable in the trigger box before I got started without it being the player pawn, but that wasn't the highest thing on my list of priorities. Getting the correct AI for the video game was more important to me than getting the keyboard inputs working. And as you can see here, I can just simply toggle the publicly exposed variable to get it to do the same thing. But that is what I spent the last 2.5 weeks working on, choosing, testing the various AI methods and choosing the right one for the game, which was a very involved process. Thank you for your time.